I didn't think we stopped while I was out.
Do you have a pass left?
Mr. Kennedy. Mr. Kennedy.
Hey guys, by the way, hey, remember I mentioned that I would use a color pencil. If you need to use a, excuse me, is Mr. Kennedy talking? The answer is yes.
I was talking to you. He answered me.
If you have a colored pencil, you can quickly go and sharpen it so that you can use it all the time. If you have one of your own colored pens, those are probably the best, but those are expensive. That's why I don't put them in these boxes.
Mr.
Anyone not have a box to get a pencil? Or
I'm not getting up and sharpening it. No, I'm not.
How many chicks do I get?
I'm already getting you my color.
I feel like I should get a free trip.
If you didn't sharpen mine,
I can use one of those two right now.
it's not sharp like sharp. Mr. Kennedy.
Okay.
Mr. Kennedy.
I was only going 1 second.
Alright, what's up? Deanna, what's up?
Is my head in that frame?
Is what?
Is my head in the
No.
frame? You sure?
Yes.
How you know?
Because I looked and I focused on the board
Oh.
when I put the camera there. Alright, so once again, no pencils anywhere on the desk. So Maddie, clear that pencil off, please. Thank
Yeah, Maddie.
you.
Listen to directions
Thank
for
you,
once.
Mike. Put that away. No pencils. Brady, pencil off your desk. Alright, so if you need to quickly get up and to grab a colored pencil at some point, or sharpen a colored pencil, that's perfectly fine. But remember, I want you to update your knowledge, update your understanding. If you are turned in a direction that you cannot easily see the board, turn your desk so you can easily see the board. It's hard to grow and learn without looking and writing those notes down. Hi, Janaya. I don't know what you're saying.
Who? Journal. Oh, no, that's the one that be going to juvenile. Oh, that's Janelle. Hey, Janaya. Janaya.
All right.
That's Janaya. She's scary.
Hey, Gary.
Who, Mr. King?
All right.
She can't trust anymore. She can't trust her jail. What the fuck?
So let's start going over this, demonstrate your understanding. Again, we're gonna go over stuff. Oh, everyone does want a calculator. One person per group, go grab a calculator because we are gonna use them to talk about a couple of these. Please do not bump into the camera as that can prevent us from
Me being the
video
camera.
well later. Here's two.
No, thank you.
You,
Don't get in front of the camera. We have to see the board.
Tyler, Preston, all y'all, since you're being lazy, there's three right there, just don't drop them. One of y'all still needs to be.
Hey, look old. Look like a lumberjack.
Okay,
Jamie.
everybody got a calculator, ready to go, ready to take some notes. Brady, you got a calculator in hand?
No, everybody don't need a calculator.
No, everyone needs a calculator.
You just said you need one calculator.
No, I said one person per group to get a calculator.
Oh, fuck. Anna Whitfield. I didn't do that.
That way we didn't have 25 people in the back. Yo, please quickly pick that up so no one steps on the box. Alright, so we're going to do a demonstrated understanding analysis, look over everything. Reminder of the whole unit of concepts and a final couple of concepts. I'm going to go ahead and tell you. So for all the complaining, I promise you that I do consistently reflect and change. There's a reason why this test was supposed to be on Wednesday and now we just did a demonstrated understanding. Because whether you realize it or not, I'm always looking and paying attention to what you're struggling with. If you listen and pay attention to when I teach, you will learn a lot. So let's engage this conversation, ask the questions you need to. Because I'm going to tell you, I'm not a perfect teacher, but I was even talking to Miss Lightfoot, because she and I are working on something together, and she watched some of the YouTube videos, and she even made the comment, man, I really like how you are using the students' work and showing how to fix and improve understanding. I'm not saying I'm doing it perfectly, but when Miss Life would even recognize it, especially one that a lot of y'all have had, and I think we can all recognize, she's a phenomenal teacher. I know something about what I'm doing. I promise you. Trust me, do what I ask you to do, and you're gonna be okay. So, let's look at this analysis to improve our understanding and actually study, actually practice, and learn this stuff. So, lots of things that we could talk about here. Hopefully, we got the degree of this function right. What degree is this?
4.
Remember, we're looking at the calculator portion to start, guys. Yeah. I push over here so you can see the board more easily. I'm just trying to help you see the board more easily. Okay. So, what degree is this? 4th. Tell me one way that we know this, because notice I said one way. There's multiple ways. So that
You got 3 turns.
okay, so one reason, now we'll remind you really quickly. So it's got 3 turns. Does 3 turns guarantee it's 4th degree?
No.
Okay, so that's one piece of evidence. So we're thinking 4th degree, right? One piece of evidence is 3 turns. Cool. What's another reason we should know that this is 4th degree?
Had 3 0 roots.
Oh, so notice it's not 3 x-intercepts. But there are how many roots?
4.
There's 3 x-intercepts, but how many roots?
4.
There's one here, right? 1 root. There's 1 root. And then there's a double root. How do we know that this is 2 roots right here, or multiplicity of 2? It bounces, right? It touches and bounces away. That's 4 total roots for a what degree? 4th degree. So notice I'm saying that's extra information, but like 4 roots in those 3 x-intercepts. What's another way? Because there are, I would say, 2 more ways that we could know that this is a 4th degree. You went off the equation. What did you look at in that equation, Taj?
There's yeah, I looked at the 0 there's 1, there's that one, not that one. That one,
There's 1 0 here.
yep, then 1 0 in that. And then there's 2 in the last one.
And so how many total zeros is that?
4.
4 zeros from the equation, right? And then I would also finally point out, what would I get if I do 2x squared times x times negative x?
4. Yeah, that's 2x to the 4.
Close.
Negative 2x to the 1.
So, 4 different ways that you could justify, hey, this is a 4th degree. I will make this note. If you just said there's 3 turns, that does not guarantee 4th degree. That indicates it's probably 4th degree. But remember, if it was 6th degree, not it is, but if it was 6th degree, what's the maximum number of turns it could have? It could have 5. But how many else could it have?
3.
So notice, being 3 turns does not guarantee 4th degree. So make sure that you add that extra piece in, but that's a good piece of evidence, right? There's lots of ways to see this. Now, the next one. I will say this. There are 2 main ways that I would have liked to have seen you do number 2. 2 main ways. Anyone know of one main way that we could find the zeros in f of x?
That little standard thing, like the little x equals negative b plus or minus.
Eventually, we can't start there though.
The 0. Is your part
Okay,
about-
so say that again, Taj.
The calculator you have.
Could you use that calculator to find the zeros?
Yes.
So one thing I want to point out is, in a simplest way for this unit, you could have just used a calculator to find the zeros. We'll do that in a second. However, if you struggled with showing evidence of understanding the zero product property, or you solving a quadratic equation, you could do what Vakari was referring to. But let's look at the calculator real quick. Let's everybody pick up the calculator, type in and graph. Okay, so I'm gonna create a graph. Was it 2x squared minus x minus 6 times, what was the next factor? X
Minus 2,
minus 2, thank you. And then negative x
minus 5.
minus 5. Okay. So that's what we should have in that graphing window. Amber, you got that typed out already? Tyler, you got that typed out on your calculator instead of texting on your watch? Scrolling on your watch? Whatever. Just want you to learn. Okay? So we should have that equation. Remember, you don't have to look up at the board because it's on your sheet of paper. Now notice, that does not look easy to look at. So what are we going to do?
Change the
So I'm going to go to menu, because that's the button that lets me do cool crap, and then Windows/Zoom. Do not zoom out. Change the window settings. Zooming out does not help a whole lot. But if I go to Windows settings, I already told you on the sheet of paper what's the minimum X you should use. -6. What's the maximum X you should use? Okay, I would go by ones on the scale, but you don't have to. But you can see that 1 on the X there. What's the minimum Y? -100, maximum Y? 200. And what scale did I use for the Y? Anyone know? It's 40, right? You can literally see that 40 on the graph paper, and I did that intentionally to help you out. Does that look a whole lot like what's on that piece of paper?
Yeah.
That's exactly how I did it. Okay? On assessments, I will give you a good scale. And it's not an assessment, you need to play around with it and find it. But when it's on assessment, I want to see that you understand these things. Okay, so, Cameron, what's the button that lets me do cool crap? Menu, okay. So what are we trying to find again? The
zeros.
the zeros. So I'm going to go to menu and then analyze graph. And then 0. And what do I need to do with that vertical line there?
Go to the far upside.
So you go to, pick which 0 you want, but I'm going to go to the leftmost one. Am I lower than that 0? Am I to the left of it?
Yes.
So I hit enter. Now what do I need?
Go to the right.
Upper bound means to the right. Do I have an x-intercept of 0 now?
Yes.
Analyze graph.
Hold on. I got a
No,
question.
0. We're looking at zeros.
Can you do like the whole all three of them at the same time?
Nope, you gotta do it separately. The calculator can only find one at a time. Okay? So let's go menu, analyze graph. I'm gonna find my next 0. And there she is. Menu,
Mine said 145 too.
analyze graph. Great. That's what it should say. 0. And there it is. So this is honestly the most efficient method to use. It's not going to show me proficiency with solving equations, but that's an efficient way to find zeros. That's something that every single one of you can do. Come on, you taking notes on it? You don't even have the sheet of paper out. Yeah, that one.
Oh, yeah, that's so.
I told you that.
Okay.
Beginning of all this.
Okay.
Sir.
I'm standing now.
Good.
Oh,
You're standing now. Okay, so, number 2, what are my zeros? And I do want to point this out, I need y'all to,
1.5, man.
so hold on to that. I want y'all to hear me clearly on this. This is not a 0. It is close, but pay attention to this. What is this actually?
Oh, exactly.
That's an x-intercept, which they're very close to each other. But x-intercepts and zeros are not exactly the same thing.
Oh, man.
What should I say for the 0?
Oh. Oh.
That's a 0. X equals -5. That's a 0. By the way, with what multiplicity?
One.
1?
Oh, Mr. K, when I asked you that yesterday, why did you not inform me?
Inform you of what?
1.
I think I literally gave you the hint that they're not exactly the same thing.
I know, but it's like,
Hey, back a second. I need you to remember this. It's not about just getting it right or wrong. If you
Yes,
put
it is.
that, no, it ain't.
Yes, it is, because I graded on
so my
it.
brain gonna do this.
Right.
Back up. Right or wrong means you get a 0 or 100%. That's it, right? Like, that's not how my grading works. can you still get evidence of understanding by writing an x-intercept? If you show me why you put that x-intercept, that's still clear evidence that you understand what it is, but it's not the proper notation. Like, that's what I need y'all to understand. Like, it's always been about evidence of understanding. That's what matters. And I hate to tell you this, and I wish we had learned it before now, your grade isn't what matters, your learning does. And if your learning happens, your grade comes out.
Grade matters.
Learning ain't never got me no good grade.
Learning.
I ain't trying to be thinking.
Learning ain't never got me no good grade.
Excuse me. Listen, you can say no learning never gave you no grade, but what I would say is no grade never gave you any learning. A grade without learning is useless for your future. And I hate to tell you that, but like, what I care about is you and your future. And what's up?
Tell me.
Oh, it's perfect. Yep, got it. Thank you.
Bye, William.
Bye.
So, your grade without actual understanding does not help you move forward in your mathematical life. It does not help you move forward in your actual life. Other than just graduating. I don't want you to graduate, just, let me.
What, huh?
Back up, back up.
You be saying the wrong stuff.
Hold up. I don't want you to just graduate. I want you to graduate and be successful.
But I'm trying to just graduate.
We trying to graduate, but this
Just let me graduate.
holding us back. Because you keep getting all these bad grades up in here.
Back up, back up, back up. Hey, listen. Back up and listen. Excuse me. If you plan on going to college, so hear me clearly on this.
I ain't
and-
going to
Can I finish talking once without people interrupting me? Thank you. If you plan on going to college, a high grade without learning is how you fail out of college. I know this because I know people who did this. So if you plan on going to college, then your learning is what matters. Not everyone needs to go to college. I wholeheartedly believe that. However, if you... Then what?
You can cheat in college. You can't do nothing up in here.
You can't cheat? Oh no! How? The villainy of Mr.
That's
Kitty.
not what I'm saying.
But if you're going into a real job, not just going to college, you're going into a trade or something like that, you know what you're going to have to learn how to do is you're going to have to learn how to learn, you're going to have to learn how to think, because not everything is exactly the same every time. You go build a house, each of those houses is going to be different. You want to go do welding, each job in welding, there may be some underlying things that are the same, but each job is going to be different. So you have to learn how to learn and learn how to think. So, getting back to it, you can argue with it, but that's the truth. So, x equals negative 1.5 with what multiplicity?
1.
And x equals
2.
with what multiplicity?
2.
We knew that just by looking at the graph. That's the most efficient path to getting there, sir.
If I did the other one, I'm telling you about X.
See, I somehow did that, but it don't look like that.
And I think that's
Okay.
equal to 2.
Excuse me, Taj is talking. Say again. So be careful. So like that the equal sign means something specific. You could say the multiplicity is 1, but it's not a variable that something is equal to. So m is 1, m dot 1, but I wouldn't use an equal sign. Thank you for asking that question though. Okay, so what Bakari was referring to, the method that some of y'all may need to learn to show proficiency and earn that check mark on the proficiency scale is if we're trying to find a 0, what do we know about this equation?
It's a static. No, man.
1 is a factor form, but 2, if I'm trying to find a 0, what do we know about that equation? Say again. It's equal to 0. And like, guys, things like that are a start for evidence of understanding. It's better than freaking out and doing nothing, that's for sure. If I have a factored form equal to 0, what can I use? Zero product property. Like, this is something we've been working on for months now. We need to know I can use my zero product property. 2x squared minus x minus 6 is equal to what? 0. Or x minus 2 is equal to 0. Or
negative 8 minus 5.
Equals 0.
Okay. Now it's a matter of solving an equation, something you've been doing since middle school. Now, this equation, not since middle school. Adding 2 to both sides of the equation, middle school. X equals 2. What can I do to solve this equation?
Plus 5.
Plus 5. The only tricky part about this is what do I need to do to make that x negative, or make that x positive?
I ain't trying to make it positive.
You need to make it positive.
Okay.
Definitely need to make it positive.
Fraction.
Okay? When you say fraction, you mean divide? What are we going to divide by? Not 1, not x,
Negative x.
not negative x,
-1.
negative 1.
Okay.
Remember, if I divide by negative x, I'm making that entire thing a 1. I don't want to make the whole thing a 1, I want to make it a 1x. So x is equal to negative 5. Hey, by the way, did we have a negative 5 on the graph?
Yeah.
Did we have a 2 on the graph?
Yeah.
So, any guesses what we're going to get from this quadratic? My guess is negative 1.5 and 2, because those are the zeros we're missing. But when I have a standard form, and again, instead of hitting people with a cord, let's pay attention. When I have a standard form of a quadratic set equal to 0, what can I use to solve that equation? So I can use my quadratic formula here. Remember, if I have a standard form equal to 0, I can use a quadratic formula. This is one of the few things that you really have to memorize because it's not super straightforward to just remember. That's an equation though. Once you memorize it, what's the opposite of b? Well, what is b, by the way?
Positive.
Well, what's b?
Hold on, be negative 1.
Negative 1, right? Negative 1x. So the opposite of b is
1.
1. Plus or minus the square root of negative 1 squared. Make sure you put your negative 1 inside of the square. Minus 4 times 2 times.
Negative 6.
They're 2, but they're doing like.
Alright, so
Wait, they're not doing it.
x equals 1 plus or minus. Remember, you can type that entire radicand into the calculator. If you do, you get 49.
Yep.
And what's the square root of 49?
7.
7. You got calculators again.
Okay.
Alright, so what is 1 plus 7?
8.
8. And 8 divided by 4 is 2. What's 1 minus 7?
6.
Close.
I mean negative 6.
Negative 6.
So I did 7 plus 1.
And negative 6 divided by 4, by the way, guys. Negative 3 halves. Calculator will do that. Or
3 halves.
negative 1.5.
You see, Mr. What? I got 3 halves, but I did opposite. I did 7 minus 1. And got 6. That is
But you need to pay attention to it's 1 plus 7 and 1 minus 7.
Why would it be before 7?
Because it is in the formula.
Oh.
Isn't that the square root right there? So it's the square 1 plus or minus the square root of 49, so plus or minus the 7. You gotta pay attention to where that plus or minus is. The plus or minus is not on the 1, it's in front of the 7. So, notice, how many times does the function equal 2? Twice, so x equals 2 with a multiplicity of 2. X equals negative 3 halves or negative 1.5, and x equals negative 5. Does it matter which of those methods you needed, or you used? Which one's simpler? I would think looking at the graph would be simpler, honestly. Now, I will point this out. It's not always a guarantee that it's going to be a nice rational number like that, so I would use the calculator, not just the paper. But if you were not strong with the zero product property and the quadratic formula before, this is a good way to show evidence of understanding. What questions do you need to ask before we wrap this little section up? You have all the notes you need to take to your future forgetful self.
Yeah, no.
Oh, no.
I know, it's a wild concept, notes to your future forgetful self. Why is cold air pumping into this room?
Mr. Kim, you still cold, huh?
I literally just said, why is cold air pumping into this room?
My man's about to freeze out.
No. Hard pass.
Come on, baby. So we.
Okay?
I told him you can come on. And I said, you can come on.
So a handful of us are still taking a few notes. The bell, not the, well, yeah, the lunch bell will catch us in about 30 seconds. So, finish taking whatever notes you need to. We will start on number 3 when we come back from lunch.
Come on, bro, class over, bro.
She's still in my room. You can do that at home.
Yes.
Your parents let you do that at home.
Dude,
If my son started doing that at home, we'd be having work.
Well, maybe you do it if you want.
I mean,
You gonna
how
get
old is
back
your
your son?
son?
He's only 2 right now, but if he started doing it when he's older, he gonna be having
I'm a grown
words.
man, bro.
You ain't no grown man.
I'm a grown
He
man.
started having.
You pay all your own.
I'm about to say,
The response was exactly what I would tell every single one of you that,
I don't believe it.
no, I didn't say that. I don't, but I said, hey, look, you learn it, and you'll pass based on how
I learned it. I got 1 more week of school before I fail.
You ain't failing.
Yeah.
Good. I haven't given up on you. One point of order I will say is, I don't remember if I mentioned this earlier, but I told y'all like I've already adjusted a lot of instruction. The test was supposed to be Wednesday. Obviously, that was nowhere close to happen. We're going to finish going over this demonstrate understanding, and for the rest, and I'm going to teach you one last thing, and we're going to review all day Monday, test on Tuesday. Because we are doing that, there's no way that I can really do the next unit. I'm going to take one day to teach you one last concept that I have to, that will be on the final if you have to take the final. But the rest of the week will, so Wednesday through Friday for the most part, will be spent reviewing for the final. And then the Monday and Tuesday after that, reviewing for the final. So even if you have to take the exam, there's lots of review to help you prepare and learn. If you don't have to take the exam, it's still good for you to review all the things we've learned so that you have that strong foundation moving forward. So, that's the plan that I developed today. You good? Huh? In here or? Yeah, it's because someone decided to bring food in and is trying to sneak it. As if no one can smell it.
Yes, I feel like
It's
some
like
song.
this actually.
Right? You walk in, you're like, oh,
Clean up your
What?
Yeah,
Somebody over there scratching it.
$12 an hour?
So, getting back to this math, okay? A lot of y'all need to pay attention because domain and range is still one of those skills that a lot of us are struggling with. And so, I'm going to go ahead and tell you the correct answers right away, and then we need to discuss and talk about where we had misconceptions. Number 3, nope. Negative infinity to infinity. Range, negative, nope. Oh gosh, why do you keep putting a bracket? Negative infinity to, I believe it's 186 or so.
Yeah, I put 200.
Well, but notice the graph goes up to, the coordinate system goes up to 200, but does this go all the way to 200?
I said,
yeah.
right now, I had to still on here.
Okay.
But where you get 186?
Well, there's this beautiful thing called a, oh, yeah. So, but let's focus on that domain first. Why is the domain negative infinity to infinity? Because you read from left to right, and what is the lowest, the minimum x value? It's going down, but it's also going left, okay? Does it ever quit going left?
Somebody tell me.
No, so my minimum x is negative infinity.
Because it's going down, right?
No, not because it's going down. Domain is about which x value? It's about x values. Down is not an x direction.
It's left and right.
It's left and right. It is going down, but it's also going left.
Yeah.
Because it never quits going left, the domain is negative, or the minimum is negative infinity. What's the maximum x?
Positive infinity.
Positive infinity, right?
Yeah.
It is going down, but the down is not what matters for domain. It's going down and to the right. Does it ever quit going to the right? So what's the maximum x? Positive infinity. Now, I do need you to pay attention to the range. Because this is an even degree polynomial, it does have an absolute maximum or an absolute minimum. And I saw at least one person make a note here, and this is a little bit for later, but I saw someone say that this was an absolute and that this was a relative. For all of y'all that were like, what in the world is a relative extrema? We've talked about it for days upon days upon days. A relative extremum is found wherever the graph what? Turns. So relative extrema can easily be seen as terms. Now, there are two different types of relative extrema. There are relative minimum and relative maximum. Those are two types. But if you see a turn, it's a relative extremum. I'll be honest, I don't know how to make that more plain. I hope that makes it sink in, helps it. But like if it's a turn, it's a relative extremum. That's it. Been working on that since before spring break. Thanksgiving break? Not spring break.
Before Thanksgiving break.
What's up, coach?
So I go walk.
Where y'all been?
I was at the bathroom, I just walked behind. I've been with him.
Yes, you are.
Okay.
Go walk.
I'm tired of
You just know me. Go walk, right?
Okay, Mike, hood on, your hat off, please. Hood, hat. Alright, so why is this not an absolute minimum?
broke you? Like a dummy.
Because that's not going to go.
Because it keeps going down. Winter, did you forget to put something up? Put it up.
And then- Oh, so I, who had that? Who had that? Come on, oh. Why you do that? Then I realized.
Can you close the door all the way, please? Thank you. Alright. So, why? So someone already said it is not absolute because what does it do? It keeps going down. When we say absolute, it is the absolute highest or lowest. Break it down to the language. Are there points below this one?
Nope.
Points here and here. So are there points below? Yes. So this is not absolute, but it is still a minimum. It's still a relative minimum. It is a turn. So this is a relative maximum.
Because on the positive side, right? That's why it's the maximum.
No.
No, it's just because it's going up. They don't
No,
know.
second high
Think
point.
there's so two things with it. One, think about it like a mountain.
Right.
Okay.
Going up.
So well, it's not just that. It's the top of the mountain.
Right.
Okay. That's a maximum. On top of the fact, the real mathematical definition is it stops increasing and it starts to decrease. Maxima exists when the function stops increasing, starts to decrease. That's why it's a maximum. What's funny, Bakari? What's funny?
I'll say nothing.
Okay.
He just be smiling.
Okay.
Smiling.
I knew it sometimes.
Alright, so
Ain't no wrong with
this
smiling.
one though, right here, hey, what is this one?
Ain't no
Absolute.
wrong with smiling.
That's absolute maximum.
And relative. It's a term, so it is relative and absolute.
Yeah.
Okay, the reason why that is important is what is the minimum y value? So when we say range, that's my minimum y. Why is it a negative infinity here?
It's going.
It's going.
It keeps going down, right? The lowest y is negative infinity. It keeps going down for forever. But when I talk about the maximum y, does it stop anywhere?
Yeah.
Yeah?
186.
At that point right there, it stops. Now, that's not something you should know off the top of your head. This is why you had a graphing calculator. This more than anything else. And we typed in this calculator already, typed this into the calculator before lunch. So how am I going to find the maximum using the calculator?
You go
Go to
window.
menu,
No, I mean menu.
You went, now we go, analyze.
And,
I wanna analyze that graph.
And go to maximum.
Oh, and there's literally an option for a maximum. That's it. And it asks for a lower and upper bound just like before, so I go to the left of my maximum, scroll to the right until I hit the right of that maximum. Now, we talked about this yesterday. I'll make sure that the calculator is in a good mode. If it says 1.9 e positive 2, I'll accept it. That's just a settings thing. If I change it to float 4, notice it'll give me 186. Okay. Now, I still need the minimum and maximum. So I'm gonna go ahead and find all of my minimum and maximum.
Huh?
Link.
I already know that. Okay.
What you
Good.
got, Madison? Y'all be leaving school. I seen y'all when I was leaving.
Only on the white side?
Wait, so the
In the range, that's right here on this side?
No. Range is bottom to top.
I need,
It's
it's
one.
white.
So it's not on one side or the other, it's bottom to top.
Yeah.
Does that graph ever quit going down?
Wait, are we talking about which one?
The range.
The range.
Range,
So-
The main X side.
Right, so range is y values, right? It never quits going down, so the minimum y is negative infinity. It never goes above that 186, so that is my maximum x. That's it. What are your questions, comments, or concerns through number 4?
None.
Do we know how to fix it if we did not get it right the first time?
Yes.
Know how to study it?
Yes.
Improve or you don't know how to study that? You sure? Okay. There are check your understanding problems that I've given you with all these. And I did make a video for my first block when I did that with them a few weeks ago. I'll share that to this class as well, on YouTube. Yes, Kalia. Just make it as a single thing like this. So make it interval notation is horizontal like that. Sir.
Well, talk to my girl. Dang, Jamie.
I'm gonna have to answer that question separately. I
That's so
gotta finish
funny,
going through this before the end class. Alright, so I need y'all to pay attention on number 5. Read number 5 again. It says identify all relative extrema for f of x. Make sure you indicate which is which and determine if one of the relative extrema is also an absolute extreme, a maximum or extremum. I didn't ask you how many there were, guys. I asked you what they are. I did not ask how many there were. I asked what they are. So I have this relative max and absolute max. I have this relative min and absolute just relative min.
So you wanted.
And I have this relative max. Huh?
So you wanted their points.
Yeah, I said what are they? What are the relative extrema?
Hey, brother, I thought you meant like. So
I know, but so if you label on the graph, that's evidence of understanding. But I do want you to actually write the points. So you do better on the test. All this doesn't matter, right? We learn from it, we grow, we get better. But make sure you add that note to yourself. If you thought I was asking how many, fix that. Mr. Kenny wants to know what they actually are, which is the language that is there. What are they? So, relative max and absolute max, relative min, relative max.
Yes.
Actually write the points for you.
Yes, Mr. Bean.
If it's a mountain, or the top of a roller coaster, it's a max. If it's a valley or the bottom of a roller coaster, it's a min. The real technical language is about increasing, decreasing. I'm gonna wait a minute to let you take the notes you need to take to improve your understanding.
What is wrong with you? You look like Christmas. You look like Christmas.
I looked at the
There's like-
it keeps going down, but it's also
And then like only this
yeah,
part
push
showing
goes
and
up. So
it's
the
red.
minimum x is negative infinity. That's the minimum x. This is going down, but it's also going to the right. But it's left versus right. So the minimum
That's
x.
very interesting.
Now, here's for some reason, that's not square root of the back half, and all of a sudden you put it in the front.
It's in the back.
You can't switch. Alright, based on the amount of random talking that's not about math, it is time to get back to it. Number 6, I believe it was, just asked about the what?
In behavior.
In behavior. Guys, I need y'all to remember the notation for in behavior, okay? Yes, I could, there are times when I want you to think through, is it the same or is it different? But
That little Buddha that locked down the phone.
But, hey, Bakari, keep your comments to yourself. Focus here. Notice, here's my ends. This is where the graph, quote unquote, ends because it never stops. And so, how many ends does every graph have? 2. We have a left-hand side. So let's start here. What is x approaching on the left-hand side? Why is it negative infinity? Not because it's going down, because it's going left.
Yes, left.
Remember, it is x right here.
Yes.
So you've got to remember, with x, we're thinking left or right. Y, we're thinking up and down.
Yes.
So what is, as x goes to the left, what's y going towards?
Y goes towards the bottom.
So it's
Down.
going down towards
Negative infinity.
negative infinity.
Yes.
It's going down, right? Winner, can you please stop messing with the stapler?
I don't think they'll stop saying that.
Yeah, it's you. On the right-hand side over here, what's x going towards?
Positive infinity
Positive infinity. Why?
because it's going to the right.
Sorry. So what's the y doing?
Oh,
Y is
that's negative
going
infinity.
towards Negative infinity. It's going down.
Oh, I thought you said Y.
I know. I did say y, but I meant like, what's the y going
Oh,
towards?
okay,
That's,
okay.
that's why I laughed. I was like, that's my fault. That was good reasoning, Luan. That was my fault. Okay. All right. That's the end of the calculator page. When you get to non-calculator, what are your questions?
No questions at all.
What's the number? That's the number 5. Okay. I'm still thinking on what the previous problem.
Sorry, look at the question. That was number 6, the in behavior.
In left, I think.
I'm ready for this.
Okay. Now, let's look at this non-calculator. I need y'all to hear me very clearly on this.
Wait, Miss Ken, hold on.
Where?
No.
Okay.
I need y'all to pay attention on number 7 here. Does anyone know which 2 we should have quickly eliminated on number 7?
3 and 5.
I would have said 3 and 5. A and B. Why should A, or sorry, A and C. Why should A and C have been quickly eliminated?
Because like, it's all numbers.
Because those are odd degrees, and what do we have going with that in behavior?
Even. It's the same.
It's the same, right? The in behavior is exactly the same. So if the in behavior is the same, then it has to be what type of degree?
4th degree.
Even degree. It just has to be even. I need to go check some other features to figure out what degree it probably actually is. The turns, how many turns we got?
4.
I got 5 turns on there.
Yeah, so it could be
1,
So what degree would it have to be?
3, 4.
It would have to be 6.
Or it could be.
Remember,
I put 4.
Kai, did you say 5th degree?
I say it could be.
But remember, if it's 5th degree, we take the degree minus 1 to get the maximum number of turns. A 5th degree has a max of 4 turns. So it can't be that. We have more than 4 turns. We had 5 turns. 6 minus 1 is equal to 5. It had to be 6th degree. It also had to be an even degree because the in behavior was the same.
Yes.
Okay?
I like pills and crackers.
The other thing that I would have added and I would have looked at, what is 100% connected to the degree?
The turns.
Not leading coefficient, not just the terms, the zeros. How many zeros are right here?
1, 2, 3,
4, 5.
4,
So
5,
4, 5,
6.
6. There are 6 zeros, right? There's that one double root, so it had to be 6th degree.
Yes.
Notice right here, and I made it a little bit bigger than I've ever made it before to try to make it more clear that that's a bounce right there. That bounce is, has a multiplicity of 2.
You gotta stop this.
The rest are a multiplicity of 1, but that double root has a multiplicity of 2, counts as 2 zeros.
Yes.
So he should have gotten 6th degree. Lots of reasons for that. Hey, J. Mike, do you not need any of this information? So, possible equation in standard form. What had to be true for that standard form? By the way, if you got number 7 wrong, you could still have got number 8 right by getting the right features with number 8, based on what you did in number 7. But what should it have been? 6th degree, so x to the 6th. What else do I need? Positive leading coefficient. Does anything else afterwards matter?
Nope.
Nope, but I need you to put something afterwards.
Yes. What if I didn't put a square on that one right here? Would that have still been valid?
Okay.
This could be anything.
Okay.
The only thing that matters is the highest power
Yeah.
and the leading coefficient.
Yeah.
Regarding, in the previous one we said it was 6th degree,
I know.
so it had to be x to the 6th.
So we put any kind of number to the 6th power, like.
Oh my
put that there.
goodness.
Well, it had to be a positive leading coefficient. Why?
Cause that
You put 25 to the
arrow.
six.
A freaking man.
Not because of the same direction, because they're both going up.
Take
If
it
it
down.
was this,
I feel like-
that would be going down to negative infinity.
Yeah.
That would be a negative leading coefficient.
So it was like a 7, you would like a 4x7.
When I think about it,
That working well?
Yeah, but it wouldn't have that same end behavior.
I mean,
Any other questions through number 8?
Oh no. I aced this test.
Good. Jamie, you good back there?
No, she
Alright, number 9. So, first things first, I want to talk about A. I need y'all to pay attention to this. Because the most common issue that I see out of students, I didn't look at y'all's, but on this A, I have a lot of people just say different or odd. And they'll say even or same here. That is not what I'm looking for.
Oh man.
Mr. Kenny, you gotta be more.
Mr. Kenny, why you so much before that?
Let's go.
Because
I feel like
every
you have to-
single time I've talked about end behavior, I have said, don't do this. I am looking for as x approaches blank, y approaches blank. Every time.
But what if you did that with it though? I'm saying, what if you did that with it though?
That's perfectly fine. Yeah. As long, what I'm saying is, you should not have stopped there. That's not what I'm looking for. When I look over here, what do I know roughly about this function?
The power of 7. I meant the
7th degree.
degree 7. You know that
But what is it being 7th degree? Tell me.
you can have 4. You can have 4 turns, 6 turns.
No.
Well, but hold on, because we're only focused on end behavior right now.
Oh.
So keep holding on to that. But the end behavior has to be what? Different, right? End behavior's got to be different
Yes.
because it's an odd degree. So it is different.
right.
Now, which of these different end behaviors should it be? That one or this one?
That one.
I don't
The
know.
second one?
It's the second one.
Why is it the second one?
For the it's an increase.
Well, hold on. The second one here is decrease.
I mean the first one the increase. Yeah.
The first one's increase.
Yeah.
And why do we want an increase?
Because you got a positive leading coefficient.
Okay. Guys, notice if you draw a quick little sketch like this, hey, that's an odd degree, overall is increasing. Now I can easily write the end behavior because I got the left-hand side here. What is x approaching on the left-hand side? It's going to the, so it's going to the left or towards negative infinity. As it goes left, it also goes
Down.
down. So what's the y approaching?
Negative infinity.
Yeah.
That's it. If we know what this end behavior, if we can draw a quick little sketch of it, the end behavior makes a lot more sense.
What was the,
I can go ahead and tell you this.
so much?
I do end behavior without drawing a graph out, but that's not because I don't need to draw the graph. I picture that in my head in order to get this end behavior. I don't have end behaviors just memorized. I picture this and then I'm like, I can visualize it now. Pictures are powerful in mathematics. On the right-hand side, what is x approaching on the right-hand side? Positive. Okay, notice it doesn't quit going right.
No.
And what's the y approaching?
Positive.
That's it.
See, that's like, this is the easiest part, for real.
Good. I'm glad you like it.
Give me like 50 questions of this on my final. No rap. You give me 50 questions of this on my final? Boy, you ain't
Sorry,
never
Mr. K stressed me and turning me.
I hope you don't never have to see you again after this anyway.
Okay,
Oh, God, I don't know how it's going.
How it's looking.
Ms. K, I'll ask you a quick question.
He said no.
You said, you just
I
think
did
it
say no.
in your head and your mind, didn't you?
Bro, he shook his head.
What is your question?
I was about to say, so, it's just like, it's just so much, that's why I'm asking, so I can get it, so I can understand. Left hand side, it was negative, because it was going down, it was going down, left, right?
Correct.
And now the, left hand side, the y value, because it's also going down, left, right?
No, Vicari. X is left and right. Y is up and down.
Right.
X is to the left. Y is down.
Yeah.
You gotta separate those. Not left and down.
I know.
Left or down.
Yes.
Okay, number 10. What do we want to notice about number 10? For end behavior.
The degree is even.
Degree is even. The leading coefficient is
Negative.
So if the degree is even, what does that tell me about end behavior?
That we got the same in behavior.
Same end behavior, because even degree.
Yes.
And the same end behavior is going down to negative infinity.
Yes.
So, there we go. Now I can visually see what that function might look like at the ends. So on the left-hand side, what is x approaching?
Negative infinity.
So notice, I'm looking at that arrow on the left-hand side, and I notice, hey, it's going to keep going left to negative infinity. As it goes left, it also goes
Down.
to,
Negative infinity.
that's it, that arrow. Pay attention to that arrow.
Positive infinity.
So it's going to the right,
Positive.
and it's going
Down. Negative.
down to negative infinity.
Yes.
I like pills and Percocet.
That's you need to keep stuff.
Yeah.
What's your question, Deanna?
Nothing.
You sure? Okay.
You might have to do this question. I want a whole bunch of these questions.
Well, you'll definitely get it on this test.
Yeah. Wait, hold on. Wait. You said test Tuesday, right?
It's Monday.
What?
It's Tuesday?
Yeah, see?
Another day.
Chill out.
Good, John.
He said it.
So, B, let's look at number 9. Let's look at B. What is the possible number of extrema for B, 9B? 6.
6, 4, 2,
Notice
0.
6 is only the
Hot max.
max, right? That's degree minus 1.
You got 4,
So it could be 6 or it could be
4,
Four,
or 2,
2,
or the
1.
0.
Oh my mother.
What?
Word to my dad.
Jeez.
So notice it should have been 6 or 4 or 2 or 0. Once you find the maximum, they come in pairs.
Yes.
Word to my dad.
He likes
Yeah, what's up?
So what? Jackie, what is going on?
6, 4, 2, or 0. In the same way, what's the possible number of extrema for number 7?
Dad, I will leave you in the cold, my dude.
3 or 1 or 0?
Not 1 or 0.
3 or 1.
Can you take away,
Oh, yeah, I
if you do 1 minus 2, does it
I
get
know,
0?
I know. It would be like -1 something.
Oh, my shoulder.
Well, but you can't have
I
it,
know.
so it's just 3 or 1.
Yes.
Okay. Question.
Where's my dad? Do you want to?
Yeah, what?
You good back there, Joe? Can't wait to go watch the video and hear what you were saying.
Where's her dad? She's her dad.
What? I'm not looking for my daddy. Mr. Kennedy, she's assuming that because.
Jackie, he just sit on your mom?
Bro,
Well, Corbin on her saying
Bro,
weird
he
stuff.
was the weird stuff, bro. Do you even have it?
Right.
Weird, get him.
Alright, 9C. How many x-intercepts? What's the maximum number of x-intercepts possible?
7.
7, right? Each 0, because how many zeros does this function have?
7.
7. How do we know it has 7 zeros?
Alright, it's power. Your high power degree.
The highest degree is
Degree,
7
degree,
because
degree,
of the
degree.
fundamental
There we go.
algebra.
Hey,
Boom.
say it one more time.
Fundamental theorem. of
Fundamental
algebra.
theorem of algebra. Guys, you cannot do it. Wait, winner. What do we need to include when we talk about the degree to figure out the number of zeros?
I just said it. Where's my
The thing
dad?
that Jamie just said, the thing that I said.
Where's my dad? You don't listen.
that algebra.
Okay, we cannot just say because the degree is 7, we need to connect the degree to the number of zeros by the fundamental theorem of algebra.
Where's my dad? You should already know that. Oh my god.
So, there is a max of 7 x-intercepts.
But if I was to put the degree right, would that give me like at least like a CE?
That is developing evidence for sure, maybe a CE.
Okay.
Okay? It depends on what I'm asking for.
Got you.
Okay?
Oh, exit.
So, what are the other options for the number of x-intercepts?
Say 5, 4, 3, 2, 1. Yeah.
Why did you stop at 1? Why didn't you do 0?
He said or imaginary.
Well, you can't have 0.
You can sometimes.
That would be imaginary though, right?
No.
Wait, what?
Hello.
Well, yes, they would be imaginary, but listen, hold on. My point is, sometimes you can have 0 x-intercepts. And I'll say this, x-intercepts can't be imaginary, 0 can be.
Yeah.
But guys, if you have an odd degree,
Yes.
an odd degree has to go from -infinity up to infinity at some point, right?
Yeah.
Yes.
If you go from every negative to every positive, what do you have to go through? What number?
0.
You gotta go through a 0.
What?
So,
No.
odd degree polynomials always have at least 1 x-intercept. Even don't. Right, because I could have had a graph like this. How many x-intercepts does that polynomial have? 0, right? Still has how many zeros over there? How many zeros does this have?
1.
None.
0.
1?
How many zeros do you have?
0.
It has 4.
Wait,
4 zeros.
It has 4 zeros.
Oh yeah.
It is a 4th degree. They could be imaginary. They have 0 x-intercepts, but it has 4 zeros. It is a 4th degree.
I can see the degree.
So, how many x-intercepts could it have? It could have had 4,
Yes,
or
but it got
3,
2 or 1
1,
or 0.
or 0.
Yes.
When it's an even degree, it can have 0 x-intercepts.
Oh my god.
And you can visually see it. Like, you can visually see it. If you take it, the x-axis, and move it down, you can see 2 x-intercepts. You can see 4 x-intercepts. You can see 3 x-intercepts. Right? Like, you can move it around so that you can see where those x-intercepts would be. Alright, 11 and 12. We gotta move quickly because I want to make scans of this and hand it back to you before we go to the weekend.
That's all up.
So, number 11. What does this tell me? Degree 4. So it's 4th degree, right?
Yes.
But it only has how many different real zeros? 2. That can only happen in 2 ways. What are they? So you could have how many double roots? You could have 2 double roots.
Yes. So you have a bounce and a bounce. Yeah.
So notice we have 2 different real zeros, right? And so that's one option here. I will point out, pay attention to your end behavior. This is saying that y is going
Downwards.
Positive.
Oh, I can
It's
see.
going
That's positive thing, so it's going.
Oh.
Y is going.
Oh.
So I check it, that's good. So that's one option. It doesn't have to look exactly like that, but two double roots.
Gotta pick up the.
But it could also, I know someone did this. What did you do?
What I did, bro?
You didn't do double roots, did you?
Nah, I did a what it's called, the curve.
So a triple root?
Yeah, triple.
Notice, that has how many zeros right there?
3.
So 1 plus 3 is 4. That's fourth degree.
Yes, sir.
But how many x-intercepts does it have?
2.
Only two x-intercepts, right? So that would have been valid as well. Either one of those, two double roots or a triple root and a single root. So pay attention to that. Nothing else would really work here. Something like this, doesn't have to be in those positions. But notice you have, I guess you're right.
What?
Depending on the language. So the way that Todd did it is you just did two imaginary. And so I guess based on the language, that's fair that it could be correct because there are only two different real zeros. So yeah, you could do it that way where there are two real and two imaginary zeros. Good idea. Possible equation.
Possible equation. You
I
can
just told you.
do 3x to the 4 plus 5x plus to the third plus 7 plus 8. No, right.
So right here, the reason this works is because it's fourth degree and the lead coefficient is positive, so it's going up.
Yes.
The last one, sorry I'm moving quickly, last one's impossible. There's two issues with number 12. If it's an odd degree, can the end behavior be the same?
No.
No. If it's an odd degree, the end behavior can't be the same. If it's an odd degree, the max number of extrema is 6.
Yes.
Or it could be 4, 2, or 0. An odd degree function cannot have an odd number of extrema. I need you to demonstrate your understandings together so I can quickly go make a scan.
You better hurry up.
No, I'm going to move slow as molasses.
I mean, you're doing that right now.
You're moving pretty slow.
Your face is moving pretty slow.
Oh my gosh, Sherry, that is horrible. Sorry, put it back.
What time is it?
Got 2 minutes. It'll take me less than a minute.
2 minutes.
Whoa, can someone please stop the recording?
The one.
Long gone.
Stop the recording.
No putting each other in danger.
I'm gonna pop the mess out your hand.